Okay, so today we're going to start our study of arc functions or inverse trig functions. So let's take some notes just so that we're all on the same page. So theta is what we use to represent an angle. It could be in radians or degrees, but theta is what we use to represent an angle measure. Write that word underneath, angle measure. We're used to doing trig of some theta. So this is trig of an angle. And when we do trig of an angle, we get out a ratio or a number. It's from the ordered pair on the circle. So what I mean by that is the following. If I go down here, and so this box down here is for examples. So example number 1, if I did cosine of an angle like pi over 6, so I'd go to pi over 6 right here, and cosine is the x right there, so my answer would be root 3 over 2. So I did cosine of an angle equaled my ratio or my ordered pair on the outside of the circle. When I do trig to the -1, so this is read as arc, and then whatever the trig function was, arc sine, arc cosine, arc tangent, arc secant, whatever it was, but this -1 we read as arc, and then whatever the trig function was. So if I do arc trig of, now these two things are going to switch place, a ratio or a number or an ordered pair. What's going to come out is my theta, my angle. So I'm going to go back down to the examples. And we're going to do number 1, but the other way around. So if I do arc cosine, now remember, and here goes the ratio. Oops. Sorry, that's supposed to be root 3. Root 3 over 2. Again, right here is the ratio, and it came from the angle pi over 6, or we could even say 30 degrees. So this was an arc cosine of a number equal the theta, or the angle. So if you think back to your trig graphs, sine, cosine, secant, cosecant, tangent, and cotangent, they all repeat over and over and over again. So what we do is we restrict them so that we only have one piece, one full up-down, so that none of the values repeat, so that what we're looking at is a function. So for this first one, I'm going to write restrictions. So when we do restrictions, cosine, his friend secant, and cotangent all have a restriction that does not include the bottom. That means it goes from 0 to pi. So these three have a restriction that go from 0 to pi. This restriction group includes sine, his friend cosecant, and tangent, and they lose the left half. So they go from, this up here is called pi over 2. We can't go through the restriction. We can't go, I'm going to draw in yellow. Don't do this though. We can't go this way because we'd go through the restriction. You can't even touch the restriction. So down here, we're going to call this negative pi over 2 because we went down this way. So I like to think of the restriction as what I call hot lava, because if you touch hot lava, you will burn and die. So never touch the red hot lava. Never touch the red hot lava. You can't pass through it. So I'm going to do it in green, but it's not a good thing. You cannot go this way and tell me that that is 7 pi over 4. That's bad, because you only can go this way because we touched the hot lava. So instead of calling it 7 pi over 4, this would become negative pi over 4. So you have your restrictions. Trig of an angle equals a ratio. Arc trig of a ratio is going to get me an angle. And then we're going to use our circle right here to answer some questions. So you have another paper, it's a white paper, it has 20 questions on it. There's another video, and in the video, I do all the odd problems for you, and then you're gonna do the even problems. So go back to Canvas and open that other video.